April 18th, 1941. Willow Run, Michigan. The farmland stretched endlessly before us. 675 acres of wheat fields and drainage ditches 30 miles west of Detroit. Nothing but flat Michigan countryside as far as I could see, except for the surveyor stakes that marked where the most ambitious construction project in American history would rise from this empty land. My name is Charles Patterson, and I was standing in a muddy field that would become the largest factory under one roof in the world, a building so massive that it would have its own weather system, so productive that it would manufacture a four-engine heavy bomber every 63 minutes, and so impossible that every German engineer who heard about it declared it could never work. I'd been a production manager at Ford's River Rouge plant for 8 years, watching Henry Ford revolutionize automobile manufacturing with assembly line techniques that made cars affordable for ordinary Americans. Now, at 42 years old, I was being asked to apply those same principles to building the most complex aircraft in the world, the consolidated B-24 Liberator, a bomber with 488,193 individual parts, 360,000 rivets, and 1,550,000 components when you counted every nut, bolt, washer, and wire. The German Ministry of Aviation had received intelligence reports about our plans through neutral Swedish contacts. Their response, preserved in captured documents, was dismissive. The Americans proposed to build aircraft using automobile assembly methods. This demonstrates fundamental misunderstanding of aviation manufacturing. Aircraft require skilled craftsmen, not assembly line workers. Their Willow Run factory will produce nothing but expensive failures. Standing in that muddy field, watching surveyors drive stakes into ground that would soon hold the foundation for 3.5 million square feet of factory floor, I understood their skepticism. What we were proposing had never been attempted. Mass production of automobiles was one thing. Cars were relatively simple. Components could be standardized, workers could specialize in repetitive tasks. Aircraft were different. Each one was essentially custom-built by skilled craftsmen who fitted parts by hand, adjusted tolerances individually, built each plane as a unique creation. We were going to change that. We were going to prove that American engineering could manufacture heavy bombers faster than Germany could shoot them down. And the Germans were going to learn that the nation they'd dismissed as incapable of serious manufacturing would bury the Luftwaffe under an avalanche of aluminum and steel produced by workers who'd never built an aircraft before in their lives. "Mr. Patterson," John Rowley, our construction superintendent, sloshed through the mud toward me, blueprints wrapped in waterproof canvas under his arm. "We've got a problem. The water table is 18 inches below grade. If we excavate for the foundations the way the plans specify, we'll be building in a swamp." This was day one, and we already had a crisis that would have stopped most construction projects cold. The architectural plans called for deep foundations to support the massive weight of machinery and assembly equipment. But Michigan's high water table meant excavation would flood immediately. Standard construction practice said you couldn't build here. Pick a different site, somewhere with better drainage and solid bedrock. We didn't have time for standard construction practice. President Roosevelt had committed to building 50,000 aircraft. Britain was being bombed into rubble by the Luftwaffe. The Germans were winning in Europe, and American industrial capacity was the only advantage we had that they couldn't match. This factory had to be built, had to work, and had to start producing bombers in 18 months. Shallow foundations, I decided. Shallow footers on compacted fill. We'll engineer the floor slab to distribute the load. The building stays on this site. Rowley stared at me like I'd suggested building on quicksand. Mr. Patterson, the machinery loads will be engineered to work with what we've got. This is where the factory goes. Make it work. That conversation set the pattern for everything that followed. Standard engineering said it couldn't be done. We'd invent new engineering. Traditional manufacturing said aircraft couldn't be mass-produced. We'd invent new manufacturing methods. German experts said American workers couldn't build precision aircraft. We'd prove that proper organization and training could turn farmers and housewives into craftsmen, producing bombers that met every military specification. The construction of Willow Run began immediately, and it was like nothing anyone had seen before. 8,000 construction workers labored 24 hours a day, 7 days a week. Concrete poured continuously. The foundation alone consumed 93,000 cubic yards, enough to build a highway from Detroit to Chicago. Steel framework rose at the rate of 300 feet per week. The building grew so fast that architects were still designing the far end while construction crews poured foundations at the near end. Albert Kahn, the architect who designed the building, created something that defied conventional wisdom about factory construction. The main assembly building stretched 1 mile in length, literally 1 mile, 5,280 feet of continuous factory floor. It was a quarter-mile wide at its widest point. The roof covered 3.5 million square feet under one span, creating an enclosed space so vast that clouds formed inside the building on humid days. Workers reported seeing fog in the far sections of the assembly line, weather conditions inside a building. The scale was incomprehensible. The main floor area exceeded 67 acres. The building used 51.8 million board feet of lumber in its construction, enough to build 28,000 five-room houses. It consumed 5.5 million bricks, 5,000 tons of structural steel, 56 miles of piping, and employed electrical systems that could have powered a city of 125,000 people. German intelligence tracked the construction through aerial reconnaissance photos purchased from neutral sources. Their assessment, found in Luftwaffe archives after the war, concluded, "The Americans are building a factory of unprecedented size. However, size alone does not guarantee production efficiency. Large factories are difficult to manage, prone to bottlenecks, and vulnerable to coordination failures. We predict significant production delays and quality problems." They were half right. The delays and quality problems would be spectacular. What they didn't predict was that American engineering would solve those problems through systematic innovation, that our production would eventually exceed every pre-war estimate, and that Willow Run would become the model for mass production that would define manufacturing for the next 50 years. By October 1941, the building was complete enough to begin installing machinery. This was when the real challenge began, transforming architectural space into functional manufacturing capacity. The B-24 Liberator we'd be building was the most complex aircraft in American inventory. Wingspan 110 feet, length 67 feet, height 18 feet, maximum takeoff weight 65,000 pounds. It had 4 Pratt & Whitney R1830 engines producing 1,200 horsepower each, carried a crew of 10, and bristled with 10.5 caliber machine guns in various turret positions. The production challenge was staggering. Each B-24 required 488,193 separate parts manufactured to precise tolerances. These parts came from 1,550 subcontractors spread across 32 states, everything from nose cones made in California to tail assemblies from Texas, instrument panels from New York to propeller blades from Ohio. All of this had to arrive at Willow Run in perfect sequence, be assembled in precise order, and emerge as a functional bomber ready for combat. Charles Sorensen, Ford's production chief and the genius behind the assembly line concept, attacked the problem with characteristic boldness. "We're going to build bombers the way we build cars," he announced at our first production meeting. "Sequential assembly, standardized components, specialized workers, continuous flow. The only difference is the final product flies." The German assessment of this approach, captured in a Luftwaffe technical intelligence report from December 1941, Ford proposes to build bombers using unskilled labor and assembly line methods. This is theoretically interesting, but practically impossible. Aircraft manufacturing requires extensive hand-fitting of components, individual adjustment of control surfaces, precise balancing of airframe elements. These tasks cannot be standardized or assigned to untrained workers. We estimate Ford will achieve perhaps 25% of their projected production rates, with significant quality defects. What the Germans didn't understand, what nobody outside Ford really understood, was the level of engineering preparation required to make mass production work. We weren't just building an assembly line. We were completely redesigning how aircraft manufacturing was done. First, we had to standardize every component. Traditional aircraft manufacturing allowed significant variation between individual planes. Parts were hand-fitted. Tolerances were adjusted during assembly. Each aircraft was essentially unique. That wouldn't work for mass production. We needed parts so precisely manufactured that any component could fit any aircraft without adjustment.
Ford engineers spent 6 months redesigning B-24 components for mass production. We created 6,000 detailed engineering drawings, specifying exact tolerances for every part. We designed specialized tools and jigs that guaranteed identical production. We established quality control checkpoints that verified every component before it reached the assembly line. Second, we had to break the assembly process into discrete, repetitive tasks. Sorensen divided B-24 construction into 537 separate operations, each simple enough that workers could master it in days rather than years. Instead of skilled craftsmen building entire sections of aircraft, we'd have specialized workers performing single operations repeatedly. One person drilling holes in wing ribs, another installing hydraulic lines, another riveting skin panels. The German critique of this approach was scathing. Reducing skilled craftsmanship to repetitive assembly work will produce aircraft that look correct but lack the subtle quality adjustments that ensure airworthiness. American bombers will be mechanically sound but aerodynamically compromised. They were about to discover how wrong they could be. January 1942. The first B-24 components began arriving at Willow Run, and we attempted our first assembly. It was a disaster. The center wing section, manufactured by Consolidated in San Diego and shipped by rail to Michigan, didn't fit the fuselage sections manufactured by Douglas in Oklahoma. The tolerances were wrong, not by much, just thousandths of an inch, but enough that parts wouldn't mate properly. Workers tried to force them together, breaking fasteners and damaging components. The assembly process ground to a halt after completing just the forward fuselage section. "This is why aircraft can't be mass-produced," one of our aviation consultants told me, barely concealing his satisfaction at being proven right. "Every plane is unique. You can't just bolt them together like cars." I reported the problems to Sorensen, expecting him to order modifications to the parts. Instead, he ordered modifications to the entire production process. "The parts aren't wrong," he said flatly. "Our assembly methods are wrong. We need to engineer precision into every stage of production, not try to fix problems during assembly. Shut down the line, we're redesigning everything." For 3 months, Willow Run produced nothing while we completely reorganized our manufacturing approach. Ford engineers visited every subcontractor, verified their manufacturing processes, installed quality control systems, and implemented standardized inspection protocols. We created master templates for every major component and required subcontractors to match them exactly. We developed new measurement tools that could verify tolerances to 1,000th of an inch in the field. Most importantly, we recognized that mass production required mass precision. Every part had to be exactly right, every time, no exceptions. It was the opposite of traditional aircraft manufacturing, where skilled workers adjusted imperfect parts during assembly. We wouldn't adjust anything. We'd make sure everything was perfect before it reached the assembly line. The Germans, monitoring our production through intelligence reports through Swiss intermediaries who photographed Willow Run from commercial aircraft, noted the 3-month shutdown with satisfaction. Ford's aircraft production has failed as predicted. Their assembly line approach has proven incompatible with aircraft manufacturing complexity. American bomber production will remain limited to traditional manufacturing methods. They were about to discover how wrong they could be. May 1942. The first complete B-24 rolled off the Willow Run assembly line. It had taken 4 months to build, required extensive hand fitting and adjustment, and emerged with numerous quality defects that had to be corrected before the aircraft could fly. By traditional manufacturing standards, it was an acceptable first production unit. By our standards, it was a catastrophe. 4 months, Soren said quietly, staring at the silver bomber sitting on the tarmac outside the plant. We need to build one every hour. We're not even close. The fundamental problem was clear. We'd created an assembly line, but it wasn't flowing. Components arrived late or in wrong sequences. Workers waited for parts, or parts waited for workers. Quality problems discovered late in assembly required disassembling sections already completed. The mile-long building that should have been an advantage had become a liability. Moving materials across 5,280 feet of factory floor created endless delays. I spent 3 weeks walking the entire assembly line, stopwatch in hand, documenting every delay, every waiting period, every inefficiency. The data was damning. Assembly workers were actually working only 42% of their time. The rest was spent waiting for parts, waiting for tools, waiting for inspections, or fixing problems that should have been caught earlier. We've built the world's largest factory, I told Sorensen, and we're using it like a traditional aircraft plant. We're not mass producing. We're just producing slowly in a really big building. Fix it, he said. Whatever it takes. Roosevelt wants 500 B-24s per month by the end of the year. Right now we're on track for maybe 50. Figure out how to get us to 500. The solution required rethinking everything about how we organize production. Instead of a single assembly line, we created multiple parallel production streams. Major subassemblies, wings, tail sections, fuselage sections, nose sections, would be manufactured in dedicated areas, then converge on the final assembly line where they'd be integrated into complete aircraft. We installed overhead conveyors that moved parts directly to assembly stations, eliminating the need for workers to leave their positions. We created toolkits pre-positioned at each workstation with every tool needed for that specific operation. We developed quality checkpoints after each major operation, catching defects immediately rather than discovering them after the aircraft was complete. Most radically, we implemented something Sorensen called synchronous manufacturing, timing every operation so that components arrived at assembly stations exactly when needed, not earlier or later. Wings arrived at final assembly precisely when the fuselage section they'd attached to was ready. Engines arrived mounted on their installations exactly when the wing sections were prepared to receive them. It was choreography on an industrial scale, requiring precise coordination of hundreds of operations happening simultaneously across 67 acres of factory floor. The Germans, if they'd understood what we were attempting, would have called it impossible. Managing that level of coordination required communication systems, tracking methods, and organizational discipline beyond anything traditional manufacturing had achieved. They'd have been right to be skeptical. It was barely possible, even with Ford's organizational resources and engineering expertise. But by September 1942, it was working. Production rates climbed slowly at first, then accelerated as workers mastered their operations and coordination improved. September 1942, 31 aircraft. October, 56. November, 78. December, 148. Each month we produced more than the previous month, solving bottlenecks, streamlining processes, improving efficiency. The workforce was expanding rapidly, from 8,000 workers in early 1942 to over 42,000 by December. This created another challenge the Germans thought would be insurmountable: training tens of thousands of workers with no aircraft manufacturing experience to build precision bombers. Traditional aircraft plants solved this through apprenticeship. New workers learned from experienced craftsmen over months or years. We didn't have months or years. We needed workers productive within days rather than years. The solution was systematic training combined with specialized tasks. Each operation was broken down into steps simple enough to master quickly. Workers didn't need to understand aircraft engineering. They needed to know how to install hydraulic line number 247 using precisely 18 foot-pounds of torque on each fitting. That could be taught in a day. We created training schools inside the plant, mock assembly stations where new workers practiced their specific operations until they could perform them correctly every time. Quality inspectors verified their work, caught mistakes, provided immediate feedback. Workers who couldn't master their assigned operation were reassigned to different tasks better suited to their abilities. What emerged was a workforce unlike anything the aircraft industry had seen. Housewives who'd never worked outside the home were riveting wing panels. Farmers who'd spent their lives working with crops were installing sophisticated electrical systems. Teenagers fresh out of high school were building components that required precision measurement to thousandths of an inch. And they were doing it well. By early 1943, quality inspections showed that Willow Run produced B-24s had fewer defects per aircraft than traditionally manufactured bombers from other plants. Our assembly line workers, following precise instructions and using specialized tools, were producing higher quality work than supposedly superior craftsmen using traditional methods. The German assessment, based on intelligence gathered through Swiss intermediaries who photographed Willow Run from commercial aircraft, was: Ford has achieved modest production increases through employment of unskilled labor. However, quality must be suffering. Aircraft produced by assembly workers rather than trained craftsmen can't match performance standards. We expect high failure rates and maintenance problems with Ford-produced B-24s. They were about to discover that systematic precision beats individual craftsmanship every single time. March 1943. The breakthrough came when we solved the final major bottleneck: final assembly and testing. We'd gotten good at building subassemblies, but integrating them into complete aircraft remained slow and problematic.
It required skilled technicians to align components perfectly, test systems extensively, verify that everything worked correctly. The solution was pre-integration testing. Instead of assembling the entire aircraft and then discovering problems, we tested every major sub-assembly before it reached final assembly. Wings were mounted on test fixtures, control surfaces verified, hydraulic systems pressurized and checked. Fuselage sections had electrical systems tested while still on their assembly stations. Engine installations were run through complete operational checks before being attached to aircraft.
By the time components reached final assembly, we knew they worked. The final assembly process became mechanical. Bolt these verified components together in the correct sequence, and the resulting aircraft would be airworthy. We'd eliminated uncertainty through systematic verification at every stage. Production rates exploded. March 1943, 196 aircraft. April, 258. May, 328. We'd gone from 1 bomber per day in late 1942 to more than 10 per day by mid-1943. The mile-long assembly line was flowing smoothly, components converging from specialized production areas, workers performing their operations with practiced efficiency, quality inspectors verifying every step. But we still weren't at capacity. The factory had been designed for maximum production of 500 aircraft per month, about 16 per day. We were approaching that number, but hadn't reached it. The limiting factor was final assembly time. Even with pre-tested components, mating major subassemblies required precision work that couldn't be rushed. Wings had to align exactly with fuselage attach points. Control cables needed precise tension. Hundreds of electrical connections had to be made correctly. It took time, and time limited production. Sorensen's solution was characteristically bold. Parallel final assembly lines. We've got a mile of factory floor. Use it. Build 4 complete final assembly lines running simultaneously. Quadruple our final assembly capacity. The engineering challenges were substantial. We'd need 4 times the tooling, 4 times the inspection capability, 4 times the coordination. But the logic was irrefutable. If final assembly was the bottleneck, multiply final assembly capacity. By July 1943, we had 4 parallel assembly lines operating. Aircraft moved down all 4 lines simultaneously, each at its own pace, converging on 4 separate completion points where finished bombers rolled out onto the airfield. Production hit 365 aircraft in July, 428 in August, 475 in September. We'd achieved the impossible. We'd created a factory that could produce a 4-engine heavy bomber every 63 minutes, 24 hours a day, 7 days a week. Workers arriving for their shift would see aircraft they'd worked on the previous day, already painted, tested, and flying combat missions in Europe. The cycle time from first rivet to combat deployment was under 30 days. The Germans finally understood what they were facing. A Luftwaffe intelligence assessment from September 1943 captured after the war. American bomber production has reached levels we did not believe possible. Ford's Willow Run plant alone produces more B-24s monthly than our entire aircraft industry produces of all types. We are not fighting American air crews. We are fighting American factories. This is a war we cannot win through tactical brilliance or pilot skill. They will simply bury us under weight of production. By the end of 1943, Willow Run employed 42,331 workers and was producing 13.4 B-24s per day on average, over 400 per month. The bombers rolling off our assembly lines were flying combat missions in Europe within weeks, replacing losses, expanding bomb groups, overwhelming German air defenses through sheer numbers. The human impact was extraordinary. Our workforce included 16,500 women, nearly 40% of all workers. These weren't women doing traditionally feminine jobs. They were welders, riveters, mechanics, electricians, doing precision work that required strength, skill, and technical knowledge. Rosie the Riveter wasn't propaganda. She was real, and she was building bombers that would help win the war. Rose Will Monroe, who became the real-life inspiration for Rosie the Riveter imagery, worked at Willow Run driving rivets on fuselage sections. She could drive 3,000 rivets per shift, each one placed precisely, each one meeting quality specifications. Her productivity exceeded that of many male workers who'd supposedly had superior training. The social impact was profound. Women earning wages comparable to men's, African Americans working alongside whites in integrated production teams, teenagers fresh from high school performing technical work that required precision and responsibility. Willow Run was demolishing social barriers through simple necessity. We needed workers, we trained them, and we didn't care about their gender, race, or background as long as they could do the job. The Germans, viewing this through their ideological lens, saw it as further proof of American weakness. A Nazi propaganda piece from late 1943 mocked American aircraft production. The Americans build aircraft with women and children, proving they lack sufficient manpower for serious military production. These inferior workers produce inferior products. German aircraft built by skilled German craftsmen will always outperform American mass-produced machines. They were welcome to believe that while American-built B-24s dropped bombs on their cities with perfect reliability, maintained by crews who trusted aircraft manufactured by women and children more than German pilots trusted their supposedly superior machines.
Peak production came in March 1944. 428 aircraft produced in 31 days. That's 13.8 bombers per day, or one complete B-24 around the clock. To put that in perspective, German aircraft industry produced approximately 39,000 aircraft of all types in 1944. Willow Run alone produced 4,476 B-24s that year, 11.5% of German total production from a single American factory. The logistics of this production were staggering. Each B-24 required 1,550,000 individual components, 360,000 rivets, 13,500 pounds of aluminum, 2,400 pounds of other metals, 110 miles of electrical wiring, 4 R-1830 engines, each containing 2,800 precision parts, 10.5 caliber machine guns, and complex hydraulic, oxygen, and fuel systems. All of this had to arrive at Willow Run in perfect sequence, be assembled in precise order, tested comprehensively, and emerge as airworthy bombers ready for combat. We managed this for 428 aircraft in a single month without sacrificing quality or safety. The German reaction to these production figures was denial followed by despair. Luftwaffe commanders simply couldn't accept that one American factory produced more heavy bombers monthly than Germany's entire aircraft industry. They attributed the numbers to propaganda, statistical manipulation, counting aircraft that weren't actually combat-ready. They were wrong. Every B-24 that rolled off Willow Run's assembly line met or exceeded Army Air Force specifications. They flew combat missions, survived battle damage, brought crews home. Post-war analysis showed that Willow Run-produced B-24s had slightly lower maintenance requirements and better reliability than aircraft from other manufacturers. Mass production had actually improved quality rather than degrading it. The human stories from Willow Run reveal the true character of American industrial mobilization. Margaret Dunn, age 19, left her family farm in rural Michigan to work at Willow Run. She'd never operated machinery more complex than a tractor. After 3 days of training, she was installing landing gear hydraulic systems, working with components that required precise torque specifications and proper sequence assembly. She worked the night shift, 10 p.m. to 6 a.m., walked 2 miles from her boarding house to the plant because gasoline was rationed, and sent half her paycheck home to help her family. I was terrified the first week, she recounted in a 1985 interview. These aircraft were going into combat. Men's lives depended on my work. But the system was designed so well that if you followed the procedures, you couldn't make mistakes. They'd broken every task down to steps so simple that anyone could learn them. I wasn't building an aircraft, I was performing one operation correctly over and over. That I could do. Thomas Washington, age 32, African American, migrated from Alabama looking for work that paid living wages. At Willow Run, he earned $1.05 per hour, more than most Southern black workers earned in a week. He worked as an electrician, installing the complex wiring systems that connected instruments, radios, weapons, and controls. The work was colorblind. Nobody cared if you were black, white, or purple, as long as you could read circuit diagrams and make connections that wouldn't fail at 25,000 feet. I ate in the same cafeteria as white workers, used the same bathrooms, got promoted based on my work quality. That factory gave me dignity along with a paycheck. Helen Murphy, age 47, widowed, mother of 3, worked as a quality inspector verifying hydraulic system installations. She'd been a seamstress before the war, had never seen an aircraft up close. Her eye for detail and systematic approach to checking work made her one of the plant's most valued inspectors. People think quality inspection means finding defects, but in a well-organized production system, you rarely find defects because they've been prevented. My job was confirming that prevention was working. I inspected maybe 200 hydraulic installations per shift. I found problems in less than 1%, and usually those were corrected immediately, before the aircraft moved to the next station. The system worked because everyone understood their role and performed it correctly.
These were the workers the Germans had dismissed as inferior to skilled craftsmen. These were the people who produced bombers at rates German engineers had declared impossible. And they did it not through superhuman effort, but through systematic organization that made excellence achievable for ordinary people.
June 6, 1944, D-Day. Of the 2,395 heavy bombers that supported the Normandy invasion, over 800 were B-24 Liberators. Many of them had rolled off Willow Run's assembly line within the previous 3 months. They dropped bombs that cleared beach defenses, destroyed transportation infrastructure, and isolated the battlefield from German reinforcements. Those bombers had been built by women who'd been housewives the previous year, by teenagers who'd never held factory jobs, by farmers who'd traded tractors for rivet guns. They'd been assembled using techniques German engineers had declared would produce inferior aircraft. They'd been manufactured at rates that German production experts had said were mathematically impossible. And they'd performed flawlessly, fulfilling their mission with reliability that validated every decision we'd made about mass production. By August 1944, Willow Run had produced 4,000 B-24s. The impact on the air war was decisive. American bombing campaigns over Europe relied on overwhelming numbers. 100-plane raids became 1,000-plane raids. The Luftwaffe couldn't shoot down bombers faster than American factories could replace them. German pilot skills and aircraft quality became irrelevant when they were outnumbered 10-1. The strategic equation had become simple. American industrial capacity exceeded German military capacity by margins that made tactical brilliance meaningless. You can't win a war when your enemy produces more bombers in a month than you can shoot down in a year. You can't maintain air superiority when replacement aircraft arrive faster than you can destroy them. You can't achieve victory through skill when you're being buried under an avalanche of production. The Germans had learned this lesson by late 1944. Luftwaffe effectiveness had collapsed, not because their pilots lacked skill or courage, but because they were overwhelmed by numbers they couldn't match. For every German aircraft produced, American factories built 4. For every German pilot trained, American schools graduated 3. The arithmetic of attrition warfare was inexorable. Given equal skill levels, the side with more resources wins. And American resources weren't just more, they were overwhelmingly, impossibly, incomprehensibly more. Willow Run alone illustrated this disparity. One American factory, built on Michigan farmland in 18 months, operated by workers with minimal training, producing more heavy bombers monthly than Germany's entire aviation industry could manufacture. September 1944. I stood on the same muddy ground where construction had begun 3 years ago, watching B-24s roll off 4 parallel assembly lines. Every 63 minutes, another bomber emerged, painted, tested, ready for combat. The mile-long factory hummed with coordinated activity. 42,000 workers performing their specialized tasks. Components flowing from dedicated production areas to final assembly. Quality inspectors verifying every step. It was the culmination of everything we'd attempted. Mass production of complex aircraft using systematic engineering and organized labor. What German experts had declared impossible was happening every 63 minutes, proven wrong by reality. Charles Sorensen joined me, watching another B-24 emerge from the factory. He said, "We did it. We built the impossible factory. Proved that American methods work for aircraft, just like they work for cars. We've produced 7,000 bombers, and we're going to produce 12,000 before we're done." He was right, but he was also missing the larger point. We hadn't just built bombers, we'd proved that systematic organization and proper engineering could achieve things that traditional methods said were impossible. We demonstrated that well-trained ordinary workers could outperform supposed craftsmen. We'd shown that precision came from systematic methods, not individual skill. Most importantly, we'd created a production model that would define manufacturing for the next 50 years. The techniques we developed, modular construction,
parallel production streams, systematic quality verification, specialized workers performing standardized tasks would become standard practice across every industry. Modern manufacturing, from aircraft to electronics to automobiles, uses methods pioneered at Willow Run. The Germans had laughed at our plans. They dismissed assembly line aircraft production as theoretically interesting but practically impossible. They predicted failure, quality problems, production disasters. They'd been wrong about everything. May 8, 1945, VE Day. The war in Europe was over. In the final accounting, Willow Run had produced 8,685 B-24 Liberators. Total production time, 43 months. Average production rate, 201 aircraft per month, or 6.7 per day. Peak production, 428 aircraft in March 1944, or 13.8 per day. Each bomber had carried a crew of 10 men into combat. Those crews trusted their lives to aircraft built by workers the Germans dismissed as inferior. Housewives, farmers, teenagers, African Americans, women, anyone who could learn the procedures and perform them correctly. And those aircraft had performed brilliantly, bringing crews home, completing missions, proving that systematic precision mattered more than individual craftsmanship. The final German assessment, written by captured Luftwaffe engineers reviewing American production methods, we fundamentally misunderstood American industrial philosophy. We believed aircraft manufacturing required skilled craftsmen and traditional methods. The Americans proved that systematic engineering and organized production could achieve superior results. Willow Run produced more bombers in 1 month than we produced in 3, and their aircraft were more reliable than ours. That captured the essential truth. World War II was decided not on battlefields, but in factories. The side that could produce more tanks, more aircraft, more ships, more ammunition would inevitably win regardless of tactical skill or strategic brilliance. And America's industrial capacity, exemplified by Willow Run, exceeded Axis production by margins that made military defeat inevitable. The Germans had spent the 1930s building military forces designed for quick, decisive victories. They'd perfected blitzkrieg tactics, developed superior tanks and aircraft, trained highly skilled soldiers. What they'd never developed was the industrial depth to sustain prolonged warfare against opponents who could outproduce them. American strategy was simpler. Build so much that tactical losses become irrelevant. Produce bombers faster than they can be shot down. Train pilots faster than they can be killed. Manufacture ammunition faster than it can be expended. Overwhelm the enemy not through superior skill, but through unlimited resources systematically applied. Willow Run embodied that strategy perfectly. One factory that outproduced entire national industries. Workers who'd never built aircraft creating bombers as reliable as any in the world. Production rates that seemed impossible until they became routine. It was American industrial philosophy reduced to its essence. Proper organization and systematic methods can accomplish anything. The human cost of Willow Run's success deserves recognition. 62 workers died in industrial accidents during construction and operation, crushed by machinery, killed in falls, electrocuted, burned. Thousands more suffered injuries. The pace of production was relentless, the working conditions challenging, the pressure enormous. But those 42,000 workers changed the world. They proved that ordinary Americans, given proper training and systematic organization, could achieve extraordinary things. They demonstrated that democracy and mass production were compatible, that free workers voluntarily cooperating could outperform forced labor. They showed that American industrial methods could be applied to any manufacturing challenge, even building complex aircraft that supposedly required traditional craftsmanship. The social impact extended beyond aircraft production. Women who'd worked at Willow Run didn't willingly return to purely domestic roles after the war. They'd proven they could do men's work, and many continued in industrial careers. African Americans who'd earned decent wages and experienced workplace integration weren't willing to accept segregation and discrimination afterward. The seeds of social change planted in wartime factories like Willow Run would bloom into civil rights movements and gender equality advances. The factory itself operated until 1945, then transitioned to automobile production before eventually closing. The building still exists, partially demolished but with sections preserved as historical monuments. It's a reminder of what American industry accomplished when national survival demanded impossibly rapid transformation from peacetime production to military manufacturing. 75 years ago, the lessons of Willow Run remain relevant. When people say something can't be done, can't be organized, can't be manufactured at required scale, remember that experts said the same thing about building bombers on assembly lines. When someone claims traditional methods are superior to systematic innovation, remember that traditionally built aircraft were outproduced and outperformed by assembly line bombers built by supposedly inferior workers. The German engineers who laughed at Ford's B-24 factory plan learned their mistake through systematic destruction delivered by bombers they declared impossible
to produce. Every B-24 that dropped bombs on German cities was proof that American industrial methods worked. Every mission flown by Willow Run-built aircraft validated our approach. Every bomber that brought its crew home safely demonstrated that mass-produced precision exceeded handcrafted approximation. The final statistics tell the complete story of what Willow Run accomplished and what it meant for the outcome of World War II. Production statistics. Total B-24 Liberators produced 8,685 aircraft. Production period was May 1942 to June 1945, 43 months. Peak monthly production, 428 aircraft in March 1944. Peak daily production, 13.8 aircraft. Fastest production time, 1 complete bomber every 63 minutes at peak efficiency. Total workers employed at peak, 42,331. Percentage of the workforce that was women, 40%, or 16,933 workers. Total manufacturing space, 3.5 million square feet, or 67 acres under one roof. Comparative production, Willow Run's 1944 production alone with 4,476 B-24s. The entire German aircraft industry 1944 production of all types was approximately 39,000 aircraft. Willow Run represented 11.5% of total German aircraft output from a single factory. Cost for B-24 at Willow Run, $215,516 compared to $297,627 at Consolidated San Diego plant. Time savings through mass production? Traditional methods required 90,000 man-hours per aircraft. Willow Run achieved 18,600 man-hours per aircraft. Combat impact. B-24 Liberators flew 226,775 combat missions in all theaters, dropped 452,508 tons of bombs, shot down 4,189 enemy aircraft. Of the 18,482 total B-24 aircraft produced by all manufacturers, Willow Run built 47%. Willow Run-built B-24s participated in every major bombing campaign from 1943 to 1945. Loss rate for Willow Run aircraft was statistically identical to traditionally manufactured bombers, disproving German predictions of inferior quality. Engineering innovation. Number of specialized tools and jigs created, over 8,000. Engineering drawings produced, 6,000 plus detailed drawings specifying exact tolerances. Assembly operations defined, 537 discrete learnable tasks. Quality control checkpoints, 87 inspection stations along the assembly line. Defect rate at peak production, 0.8%, meaning 99.2% of aircraft passed all inspections on the first attempt. Average training time for new workers,
4 to 7 days to competency on assigned tasks. Workforce demographics. Women workers, 16,933, or 40%. African American workers, approximately 2,500, or 6%. Workers under age 21, approximately 8,500, or 20%. Workers with previous aircraft manufacturing experience, less than 5%. Average wage, $1.05 per hour, equivalent to approximately $17.50 per hour in 2024 dollars. Total payroll at peak, $44.4 million annually. These weren't just numbers on production reports. They were families fed, careers launched, social barriers broken, and most importantly, lives saved. Every B-24 that completed its mission meant 10 American aircrew members came home. Every bomber that absorbed battle damage and brought its crew back safely validated the engineering that went into its construction. Every mission flown proved that systematic American manufacturing methods produced aircraft that performed exactly as designed. I remained at Willow Run through the end of production in June 1945. The final B-24 rolled off the assembly line on June 28th, painted in ceremonial colors, signed by hundreds of workers who'd contributed to its construction. We'd built 8,685 bombers in 43 months, transformed 675 acres of Michigan farmland into the world's most productive aircraft factory, and proven that American industrial methods could accomplish what German engineering had declared impossible. The day after that final aircraft was completed, I walked the mile-long assembly line one last time. The machinery was silent. The conveyor systems stopped. The workstations empty. It felt wrong somehow. This space that had hummed with coordinated activity 24 hours a day for 3 years was now quiet, its purpose fulfilled, its mission complete. But the legacy of what we'd accomplished would echo far beyond Willow Run's walls. The production techniques we had pioneered would be studied and copied by manufacturers worldwide. The systematic approach to quality control would become standard practice across every industry. The proof that mass production and precision manufacturing were compatible would revolutionize how complex products were built. Most importantly, we had demonstrated something that the Germans had never understood: that democracies, mobilizing their full industrial capacity, could outproduce totalitarian states despite, or perhaps because of, their freedom and diversity. Our workforce of housewives, farmers, teenagers, and workers from every background built bombers that helped win the war precisely because they were free people, voluntarily contributing to a cause they believed in. The Germans had built their war machine through forced labor, concentration camp workers, and conquered populations compelled to produce for their conquerors. We had built ours through classified ads, competitive wages, and the simple American belief that ordinary people, given proper training and organization, could accomplish extraordinary things. The results spoke for themselves. Germany's forced labor produced inferior products with high defect rates and required constant supervision. American free workers produced superior products with low defect rates and needed minimal oversight once properly trained. Democracy and industrial efficiency weren't contradictory, they were complementary, each reinforcing the other. In 1985, 40 years after the war ended, Ford Motor Company held a reunion for former Willow Run workers. Over 3,000 people attended, men and women in their 60s and 70s, many bringing their children and grandchildren to see where they'd contributed to history. Rose Wilman Rowe attended, still energetic at 67 years old, still proud of the work she'd done driving rivets on B-24 fuselages. Margaret Dunn came from her retirement home in Florida, bringing photographs of herself at 19 years old installing hydraulic systems. Thomas Washington traveled from his home in Detroit, where he'd built a successful career as an electrical contractor using skills learned at Willow Run.
Charles Sorensen, then 94 years old, gave a brief speech that captured what Willow Run had meant. We didn't just build bombers here. We proved that American industrial democracy could outperform any system based on compulsion or ideology. We showed that ordinary people, properly organized and fairly treated, could accomplish things that experts said were impossible. We demonstrated that mass production and quality weren't contradictory, but complementary. Most importantly, we proved that free workers building for a cause they believed in would always outperform slaves building for their masters. The crowd gave him a 5-minute standing ovation. These were people who understood what they'd accomplished, who'd lived through the war and seen their work contribute to victory, who'd carried the pride of Willow Run through 40 years of peace. I spoke briefly, sharing stories of the muddy field where it all began, the engineering challenges we'd overcome, the production records we'd set. But what I remember most from that day was talking with the workers afterward, hearing their stories, understanding how Willow Run had changed their lives. Helen Murphy told me about her 3 children, all of whom had gone to college on money she'd saved from her Willow Run wages. That job gave me independence, she said. It showed me I could do technical work, could understand complex systems, could contribute something important. After the war, I never went back to being just a housewife. I worked as a quality control manager for 25 years. Willow Run changed who I thought I could be. Thomas Washington talked about workplace integration. I'd never been treated as an equal by white workers before Willow Run. Oh, there was still prejudice, still problems, but the work demanded excellence regardless of color. That factory showed me that integration was possible, that people could work together based on competence rather than race. It gave me hope that America could change, and I spent the next 40 years working to make that change happen. Margaret Dunn spoke about women in manufacturing. We proved women could do precision technical work. We proved we could handle the physical demands. We proved we could master complex systems just as well as men. When people tell me women can't do something, I think about installing hydraulic systems on B-24s when I was 19 years old. If I could do that, women can do anything. These were the real stories of Willow Run, not just production statistics and engineering triumphs, but human transformation, social progress, proof that American industrial democracy worked not just economically, but morally. We'd built bombers, yes, but we'd also built a model for how diverse workforces, working toward common purpose, could accomplish the impossible. The German engineers who'd laughed at Ford's B-24 factory plan learned their lesson through systematic defeat, delivered one bomber at a time. Every B-24 that appeared over German skies represented their miscalculation. Every bombing raid that destroyed their factories demonstrated American industrial superiority. Every month that American production increased while German production stagnated proved that their assessment had been catastrophically wrong. After the war, captured German industrial planners were brought to Willow Run to study American production methods. Their reaction, recorded in debriefing documents, was uniform disbelief followed by grudging admiration. One German production engineer stated, "We believed aircraft manufacturing required traditional craftsman methods. We were wrong. The Americans understood that systematic engineering and proper organization could achieve higher quality at vastly greater quantities. They didn't build better aircraft. They built a better system for manufacturing aircraft. That was the difference that won the war." Another German engineer, examining the assembly line equipment and production documentation, noted, "This factory represents industrial thinking we never achieved. Every component precisely engineered, every operation exactly defined, every worker trained to perform specific tasks correctly. It's manufacturing as science rather than art. We were still practicing craftsmanship while they had moved to industrial precision. We never had a chance." Most tellingly, a Luftwaffe logistics officer who'd struggled throughout the war to maintain German bomber fleets made this observation: "American bombers built at Willow Run had better reliability than our traditionally manufactured aircraft. Their systematic production methods produced more consistent quality than our supposedly superior craftsmanship. They proved that mass production, properly executed, exceeds custom production in both quantity and quality. This contradicts everything we believed about manufacturing. That contradiction, that mass production could exceed traditional craftsmanship in quality while vastly exceeding it in quantity, was the fundamental insight that German industry never grasped. They remained committed to traditional methods, skilled craftsmen, individual excellence, and paid for that commitment with systematic defeat. Willow Run operated as an aircraft factory for just 43 months, but its impact extended across decades. The production techniques pioneered there became standard practice in manufacturing worldwide. The systematic approach to quality control influenced every industry from electronics to pharmaceuticals. The proof that diverse workforces could be rapidly trained to perform precision work opened careers to populations previously excluded from technical manufacturing. Modern manufacturing owes direct debt to Willow Run. Lean manufacturing principles, just-in-time inventory management, systematic quality verification, modular assembly methods, all trace their lineage to innovations developed on that mile-long assembly line. When manufacturers talk about continuous improvement and process optimization, they're using vocabulary that emerged from Willow Run's systematic approach to aircraft production. The building itself stands as historical monument. Portions have been preserved by the Yankee Air Museum, restored to show what the assembly line looked like at peak production. Visitors can walk the factory floor, see the specialized tools and jigs, understand the systematic organization that made impossible production rates routine. It's a reminder of what American industry accomplished when national survival demanded transformation from peacetime manufacturing to military production. But the real monument to Willow Run isn't the building or the production statistics. It's the changed world those 42,000 workers created. They proved that American industrial democracy worked, that diverse workforces performed brilliantly, that systematic organization achieved more than individual excellence, that free people working toward common purpose will always outperform those working under compulsion. The German engineers who laughed at Ford's B-24 factory plan learned through defeat that their assumptions about manufacturing, labor, and industrial organization were fundamentally wrong. American methods proved superior, not just incrementally, but categorically, better in every measurable way. That lesson resonates 75 years later. When authoritarian systems claim superiority through control and discipline, remember Willow Run. When someone suggests that diverse workforces can't achieve excellence, remember the housewives, farmers, and teenagers who built bombers. When experts declare something impossible using traditional methods, remember that Ford said the same thing about traditional methods and proved systematic innovation works better. I'm 92 years old now, living in retirement, but still thinking about those 43 months when we accomplished the impossible. Sometimes I drive out to Willow Run, walk through the preserved sections of the factory, remember the sound of rivet guns and assembly line conveyors, recall the organized chaos of 42,000 people building bombers around the clock. Young people ask me what it was like, how we did it, whether we knew we were making history. The truth is simpler than they expect. We were solving problems, meeting production quotas, building aircraft as fast as we could because the war demanded it. We didn't think about historical significance. We thought about getting tomorrow's bombers out the door. But looking back, I understand what we accomplished. We proved that American industrial methods could achieve what traditional manufacturing couldn't. We demonstrated that systematic organization and proper engineering could overcome any production challenge. We showed that ordinary people, properly trained and fairly treated, could build complex precision equipment better than supposedly superior craftsmen. Most importantly, we validated the fundamental promise of industrial democracy, that free people working toward common purpose will always outperform those working under compulsion. The 8,685 bombers we built were proof of concept, proof that democracy and industrial efficiency were complementary, that diversity strengthened rather than weakened production capability, that systematic American methods represented the future of manufacturing.
The Germans who laughed at our plans learned their mistake through systematic defeat. Every B-24 that flew from Willow Run represented their miscalculation. Every bombing mission proved their assessment wrong. Every month of increasing production demonstrated American industrial superiority. They'd believed aircraft couldn't be mass-produced. We produced one every 63 minutes. They'd predicted quality problems. We achieved better reliability than traditional manufacturers. They'd claimed unskilled workers couldn't build precision aircraft. We proved that systematic training and proper organization made excellence achievable for anyone. In the end, Willow Run didn't just win production battles. It won the philosophical war about how modern manufacturing should be organized. The future belonged not to craftsmen building individual products, but to systematic methods that made precision manufacturing accessible to everyone. 75 years later, that future is now. Every modern factory uses principles pioneered at Willow Run. Every manufacturer employs systematic quality control methods we developed. Every production line reflects lessons we learned building bombers on Michigan farmland. The German engineers who laughed at Ford's impossible factory plan would recognize their mistake if they could see modern manufacturing. The assembly line methods they dismissed as unsuitable for aircraft now produce everything from smartphones to spacecraft. The systematic organization they declared would fail has become the foundation of global manufacturing. The diverse workforce they claimed couldn't achieve excellence has become the standard for industrial production worldwide. We built 8,685 bombers in 43 months, but we created something more lasting. Proof that American industrial democracy works, that systematic methods achieve the impossible, that ordinary people given proper organization can accomplish extraordinary things. That was Willow Run's real victory, and it's a lesson the world still learns from today.